Okay, so 3.7 is graphing rational functions. These are the main important cases for horizontal asymptotes. So for case 1, the degree of the denominator is bigger than the degree of the numerator. That means the horizontal asymptote is y equals 0. Case 2 says the degree of the denominator is equal to the degree of the numerator. That means that the horizontal asymptote is going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. Case 3, the degree of the denominator is smaller than the degree of the numerator, which means there is no horizontal asymptote. If the degree of the numerator is 1 more than the degree of the denominator, then there is a slant asymptote, and the slant asymptote is y equals mx plus b in order to find it. Find the slant asymptote by doing long division or synthetic division if possible. Ignore the remainder. So, graphing rational functions, factor the numerator and the denominator and state the domain. So the first thing we'll do is state the domain. Second is cancel any common factors. Set any factor that canceled out equal to 0. These x values will be a hole in the graph. So if you cancel any values out, they will classify as holes. Find the ordered pair of the hole. Step 3 says find all the vertical asymptotes. Set the remaining factors in the denominator equal to 0. These equations will be the equations of your vertical asymptotes. Graph them both, or if one, then that. Number 4 says find the horizontal asymptote or the slant asymptote using the 3 cases. So I'm going to look back at all the cases when doing that and then graph your horizontal asymptote or whatever slant asymptote. Number 5 says find the y-intercept by plugging 0 in for x and graph that. Step 6 says find the zeros by setting the numerator equal to 0 and then graphing it. Step 7 says make a table or some type of t-chart. Make sure you have enough points to figure out how the graph is going to look. This part we'll actually use a calculator to graph it and look at our table to find points. Last step, step 8, complete the graph of the function. Make sure it passes the vertical line test. All right, so we have a lot of steps to take care of. We're going to look at step number 1. Step number 1 says first, before we even kind of do anything, let's kind of go ahead and simplify this function. So we have 1 over x squared minus 9 can factor into x plus 3 and x minus 3. Part 1 is where we find our domain. So the domain of this function goes from negative infinity to 3, union negative 3 to 3. Sorry, this should be negative 3. So negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. When we look at step 2 talks about any holes. Well, we don't have anything that cancels out anywhere, so we don't have any holes. Step 3 talks about how we set each denominator equal to 0 and solve, and that will give us our vertical asymptotes. So we have x plus 3 equals 0 and x minus 3 equals 0. So x is going to equal negative 3 and x will equal positive 3. So that means our vertical asymptotes are going to be at x equals negative 3 and x equals positive 3. So I'm going to go ahead and plot those points. So at x equals negative 3, I have a vertical asymptote. And at positive 3, I have another vertical asymptote. Okay, step 4. Oops. Step 4 says for us to look at our cases. So we're going to look at the cases for step 4. So I look at the cases. I notice that I have a lowercase t over capital D type setup, which simply means the degree of the denominator is bigger than the degree of the numerator, which means my horizontal asymptote is going to be y equals 0. So I'm going to graph that as well. Horizontal asymptote is at y equals 0. All right, so the next one is step 5. Step 5 tells us to find our y-intercept. So in order to find your y-intercept, we let the denominator set equal to 0 for x and solve for y. So we have y equals 1 over 0 squared minus 9, which equals 1 over negative 9. So your y-intercept reads 0, negative 1 over 9. So that is our our y-intercept. Part 6 says identify if there is a x-intercept. Well, we know that there are no x-intercepts in this one, simply because if we let it equal 0, 1, if we solve it, 1 does not equal 0 in our case, if you were to go ahead and solve that. So there's no x-intercept. Step 7 tells us to go ahead and create our table. So with a set of x and y's for our table. I'm going to go ahead and go back up here and plot the y-intercept, which is negative 1/9, which is possibly right about. So I'm going to go ahead and throw this in my calculator and graph this so I can find some table points. So this is the image of my graph. So roughly you can see the vertical asymptote and the horizontal asymptotes. So if I go ahead and find my table here, second table, this is my table for my actual graph. So notice I only have one table, as I should, and you can always break it down and do the math of different points. So I have 3 tables simply counting out -4, -5, and -6, which give me about 0.14, 0.06, and 0.04. And then for this one, I did -2, -1, 0, or sorry, -2, -1, 1, and then 2. When I plugged in those values, you get -0.2, -0.125, -0.125 again if you round it, and for 2 you get -0.2. Then for the last part I just did the positive, which would be 4, 5, and 6. So I got 0.14, 0.06, and 0.04. And again, you can make one table and use the tables that are provided here to kind of calculate everything, but just noticing that there's going to be a set of 3 different graphs, I went ahead and broke them down into 3 different parts to represent the 3 different graphs. So I'm going to go ahead and graph this function. So on my graph, it'll pass through this point of -1/9. the value here. It's close to the vertical asymptote through it. And this is the steps and procedures to graph a rational function. Okay, so the next example, y equals x plus 1, x squared minus 1. We're going to go ahead and simplify this a little bit. So we'll have x plus 1 over x plus 1 times x minus 1. Notice here that we can kind of go ahead and cancel some things, which gives us 1 over x minus 1. So the first thing that we're going to do is we're going to look at the domain. So I'm looking at my domain from my original function. So my domain goes from negative infinity up to negative 1, union negative 1 to 1, union 1 to infinity. Number 2, we're talking about looking at our values for if we have a whole. Well, in our case, we did have some cancellation here, which is x plus 1 and x plus 1. So we're going to take x plus 1 and set it equal to 0, which gives us x equals negative 1. And then that gives us our x value, but we have to figure out exactly what our y value is because remember our wholes have to have ordered pairs. So in order to find our y value, we do y equals our x, which is negative 1. Oops, I'm sorry. We'll do our x value, which is y equals 1 over the x, which is negative 1 minus 1. So we're using our actual simplified form once we have canceled out the common areas, which are these two. And that gives us negative 1/2. That tells me that my whole is at the point negative 1, negative 1/2. So I'm going to go ahead and graph that. So at negative 1, down 1/2, there is an open circle. Part 3 says to identify exactly what your vertical asymptotes are. So vertical asymptotes, we set the denominator equal to 0, which now we're focusing only on the part that's simplified. So we have x minus 1 equals 0. Tells us that x equals positive 1 is our vertical asymptote. So I'm going to go ahead and graph that one. And so at positive 1 is our vertical asymptote. Then let's go back and we do portion number 4. Part 4 talks about finding our horizontal asymptote. Well, in our case, the denominator of the exponent, our power of the denominator is larger than our power of the numerator, which means our horizontal asymptote based on those rules tells us that y equals 0. The next part, number 5, we have to identify what our y-intercept is. So in order to identify our y-intercept, we take y and plug it into our equation, put x in for 0 and solve for y. So we have y equals 1 over 0 minus 1, which equals negative 1. So our horizontal asymptote is 0, negative 1. Our y-intercept is 0, negative 1. We'll go ahead and type that. So it's 0, negative 1. Right. Then we have part 6, which we'll do in the next video.